So this is the last week of New Year 12 content. Okay, so last little bit to get finished. On to natural logarithms. So we know that we can inverse a logarithm by matching the base. Okay, so the inverse of log base a to the x will be a to the power of x. We're now going to look at what the inverse is of e to the x. Now this can be written as log base e to the x, but it's got its own special name and function, and it's log natural. Okay, make sure you can find it on your calculators. Okay, it's on the far right hand side, second row down, and that will be the inverse of e to the power of x. So nice and simply, we can do log natural e to the x, and it will work exactly the same as if you've got a log. Okay, so you should get just x on its own. Okay, because the log natural and the e to the x disappear. And the same if you do it the other way around, you will still get x. Okay, so a quick demonstration on what that will mean. So if we've got e to the x, okay, all we need to do is if we log natural both sides, okay, K.61, 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 K.61. Okay, again, you can leave it in exact form, leaving it in log form. 2 log natural x plus 1 equals 5. The same as what you do with the logs. In order for it to work, you have to just have that on one side. Okay, so first thing, we'll move the 2 by 2 by 2 by 2 by 2 to give you 2 on that side. Now we can do e to the power of both sides, and obviously that e to the power will cancel out the log. So x is going to equal e squared, which means x will equal roughly 7.39. Okay, really nice and simple. Your normal logs. Okay, just a slightly different name for it. Okay, right. Quadratics or hidden quadratics. We've done loads of these, haven't we? Okay. Exactly the same idea. Now you can go straight to factorising. You can use substitution. Either way, okay, doesn't matter which. So if we use the substitution to begin with, you're going to have y equals e to the x. Okay, so that means we'll go to y squared plus 2y minus 15 equals 0. You can factorise, you can solve using quadratic formula, however you need to, as long as you show you're working, same as usual. So we will go with y plus 5 and y minus 3 equals 0. So we can have y equals minus 5 and y equals 3. But obviously we aren't using y, we're using x. So e to the x equals minus 5 and e to the x equals 3. Inverse of e to the x will be to log natural both sides. So that cancels out the e. So x will equal the log natural of minus 5. And we do the same on this side. Log natural both sides so we can cancel the e. X will equal log natural 3. Exactly the same with normal logs. We cannot log natural of minus 5. So we've just got the one answer, which is when we do log natural of 3, which is somewhere around 1.09. The same process, guys. The same process, guys. The same process, guys. This one, again, one of the slightly trickier ones. Let's put it into a form that makes a bit more sense to us. So all I'm going to do is drop my e to the x down. And now it's up to you how we work from here. You can move things around first. But if we multiply everything, so if we multiply both sides, e to the x, so every part gets multiplied up, what we end up with is e to the 2x minus 2, because e to the x times by a denominator of e to the x will cancel out, okay, and that will then equal e to the x. Rearrange, and we are back into our quadratic again. This time, just to show you the other way, rather than making the substitution, you can factorise straight away. So we know we're going to have e to the x and e to the x. We're going to have a minus 2 and a 1. So I can have e to the x equals 2 and e to the x equals minus 1. Either way you want to use, guys, it does not matter. Whichever makes more sense to you. solve both of these, so I'm going to log natural both sides, so we can cancel out the e. X will equal log natural 2. Same on this one, log natural both sides. X equals the log natural of -1, which we can't find. So just got x equals log natural 2, which will be somewhere around 0. Nice and simple, exactly simple, exactly the same idea as what you've already done, guys. Okay. Right. Take a pause of the video for me. Okay. And can you have a go at the questions that are going to come up? Okay. Right. Let's have a quick look at these then, guys. So, log natural 3x plus 1 equals 2. Well, we've got the log on its own on one side, so I need to counterbalance my log natural. So I'm going to e to the power both sides. So I'll end up with 3x plus 1, because that e to the power and the log natural cancel. On its own. So 3x will equal e squared minus 1. X will equal e squared minus 1 over 3. You can leave it in exact form. You can solve fully. And we should get 2.13. Okay. Next one. This is our hidden quadratic. Get everything over to one side first. And then we can solve using either method, either substituting or go straight into factorising. It doesn't matter. So if we use substitution this time, y is going to equal e to the x. So I'll have y squared plus 5y minus 6 equals 0. So I'll have y plus 6, y minus 1. So y can equal minus 6 or y can equal 1. Put your e to the x back in. E to the x equals minus 6. E to the x equals 1. Hopefully we can begin to notice this is not going to give me any solutions. Log natural both sides on this one, and I will end up with cancelling my e out. So x will equal log natural 1. Hopefully we can remember whenever we log natural 1, we're just going to be left with x equaling 0. Okay. Last one, definitely the hardest. Got to use a bit of our laws of logs as well. Okay, so what we're going to do is we're going to log natural both sides first. So I'm going to have my log natural of 2 to the x e to the x plus 1 equals log natural of 3. Now I'm going to use my log laws to separate these, because the 2 to the x and the e to the x plus 1, okay, are multiplied in here, which means they can be written as my two separate logs when I add them. Okay. Remember, we can always go backwards and forwards using those laws of logs. I need to get x down. Again, my laws of logs, I can drop my power down. So I can have x equals log natural 2. Move my 1 over to the other side. X log natural 2 plus x equals log natural 3 minus 1. Factor out x. Log natural 2 plus 1 equals log natural 3 minus 1. Divide underneath, so I'll be left with x equals log natural 3 minus 1 over log natural 2 plus 1. Okay, and that would be it in exact value, which is what it's asked for. Okay, so nothing particularly new or different, guys. It's just using log natural instead, so it's just using ln. Apart from that, it's exactly the same work as we've been doing. Okay, right. If you look back on to show my homework for me and have a look at what questions I want you to attempt from the next exercise.